Let's take a look at finding the arc length of a circle. So if we're taking a look at our circle, obviously we're going to have some radius that's going to go from the center out to the circle itself. We're going to let r stand for the radius. I'm going to have some type of angle measure. I'm going to call that theta. In this case, you always want your angle measure to be in radians. So if you happen to have a problem where they give it to you in degrees, you're going to have to convert to radians first. And we're going to let S be the letter that represents arc length. So the arc length would be this segment of the circle that we would be looking for. Now your formula here is S equals R times theta. There's another way you can go about doing this where maybe the angle was given to you in degrees and arc length is related to the circumference. You obviously don't have the whole circumference of the circle, you just have a small component of it. So if you would like to use the circumference formula while doing this, you could do that as well. Your circumference formula for a circle would be 2 times the radius times pi. And keep in mind you don't have the whole circle, you just have a small piece of it. So if you were looking for your arc length, you would take your circumference, which is 2 times pi times r, and you're going to multiply it by whatever degree measure you're working with out of 360. Since you'd have 360 degrees in the full circle, you just have a small portion, like let's say 120 degrees. So let's go ahead and look at this example. We want to find the length of the arc, and they're going to give us a radius of 2 meters and an angle measure that's already in radians. We're going to have 0.25 radians for our angle measure. Since my angle measure is already in radians, I'm going to go ahead and use that formula, S equals R times theta. My radius was 2 meters, and my angle measure in radians was 0.25, and I can multiply those to get my answer. My arc length here is going to be 0.5 meters. Make sure you're putting units on these, since these would be application problems. Let's also take a look at finding the area of a sector of a circle. While we're working with a circle, we're still going to have our radius. We're still going to be taking a look at some angle measure. We're going to go ahead and call that theta for right now. And for the area of this sector, we're going to be taking a look at the area of the shaded region. So in this example, we're going to let A stand for the area, R is going to stand for our radius length, and theta is going to represent our angle. Keep in mind you're going to be measuring that in radians. So the formula we're going to be using here would be area equals 1/2 times r squared times theta. Keep in mind you're also more than welcome to go back to the area of a circle formula that you already know. That would be pi r squared. And since you're not working with the entire circle, you would just be working with a portion of it. You would take that pi r squared and multiply it by your degree measure over 360. Either one of these two formulas would be appropriate for this section. So let's go ahead and take a look at this problem. We want to find the area of a sector of a circle, and we're given a radius of 2 feet and an angle measure of 30 degrees. So let's go ahead and take our angle measure and let's convert this to radians. Keep in mind when you're working with the 30 degrees, you want to multiply it by pi over 180, which is going to give you the same thing as pi over 6 radians. So let's go ahead and plug in the components that we know. Our formula is 1/2 r squared times theta. Remember that theta had to be in radians, which is why we converted it up here. So I've got 1/2 times 2 squared times pi over 6. And this is going to give us an area of 1.05 square feet. Now I'm going to go ahead and do this problem using that other formula that we talked about. We could have just used our area of a circle formula, which is pi r squared, and multiplied it by our degree measure, obviously out of 360, to account for the sector that we were talking about. Let's go ahead and do it this way as well, just so we can see that it comes out to be the exact same answer. So I went ahead and plugged in my 2 for my radius, and in this portion, my degree measure was 30 degrees. That was what I was initially given in my problem. I don't have to change it to radians if I'm going to be using that formula. And when I multiply this out, I'm going to get 1.05 square feet, which is the same answer that we had over here. So you can do it either way, your preference, whichever one you're more comfortable with.